Welcome back to 3 Inquisitive Kids. Today we're going to resume our AMC8 course with a new topic, angle chasing. This is one of the first lessons that we're going to be putting into our geometry section of the AMC8 course. So here we have two problems. The first one is sort of like a warm-up problem. With each problem, you'll find a different way to solve angle chasing problems. Well, angle chasing is just using our knowledge of angles to use one angle to find another angle in certain geometric problems. And it usually comes in with triangles, but it can come in with any other polygons as well. And I suggest you to go and memorize basic concepts such as the interior angle sums of different types of polygons before diving into this course. But let's first start with our first problem. In triangle ABC, AB is equal to AC and angle A is equal to 40 degrees. The bisector from angle B intersects AC at point D. What is angle BDC? Well, the first thing we do when looking at a problem like this, which hasn't given us a picture yet, is to, make one. So we know that AB is equal to AC, which means that two of these sides are equal, meaning that this is an isosceles triangle. So AB is equal to AC. And let's mark out all of the stuff we know about isosceles triangles. We know that their two sides are the same, and their two base angles are the same as well. Angle A is 40 degrees. So the bisector from angle B, so angle B is bisected, intersects AC at point D, so that looks about right. What is the angle of BDC? So BDC, this angle right here. So we're trying to find angle X. Well, when approaching angle problems in geometric problems such as this one, the first thing we can do is try to see if we can solve it using interior angle sums, because oftentimes that is the best place to start. So we know that the interior angle sum of triangles is 180 degrees for triangles. So we know that angle A, angle B, and angle C have to add up to 180 degrees. But we already know that angle A is 40 degrees. And because angle B and angle C should be the same, we know that 40 plus angle B plus angle C is equal to 180 degrees. Meaning that angle B, which is also angle C, is equal to 70 degrees each. So angle C is equal to 70 degrees. Now we have to define a very important word here, a bisector. What is a bisector? Well, a bisector is, if you break it apart, bi and sect, is just a line segment that splits an angle in half. So it's bisecting 70 degrees, meaning that this part right here is 35 degrees. Now we're trying to find X. We now see that we have the 2 out of 3 angles of another smaller triangle. So now we do 35 plus 70 plus the measure of angle X is equal to 180 degrees. And if we solve, we'll find that X is equal to 75 degrees. Therefore, the angle BDC is 75 degrees. And that is our final answer to the first problem. So really, now we know that when solving angle problems like this, we're really trying to look for the interior angle sum. So when you have a triangle, just try to find the values of as much angles as you can. Because once you have two of the angles of a triangle, you automatically can find out the last one. Now let's try another problem. Point P lies inside triangle ABC such that angle PBC is equal to 30 degrees and angle PAC is equal to 20 degrees. If angle APB is a right angle, how can we find the measure of angle BCA in degrees. Now pause the video and try to see if you can solve this problem on your own. So we're going to use the concept of interior angle sum combined with some algebra to help us solve this problem. The first step is to mark all of the information we know from the problem. We know angle PBC is equal to 30 degrees, and we know angle PAC is equal to 20 degrees. We also know that APB is a right angle. And we're trying to find BCA, which is this value right here. We're going to call that X. So as you can see, if we were going to find the angle measure of X, we first have to know the two other angles of the same big triangle. However, we only know one part of it. We only know that this angle is composed of a 20-degree angle in PAB, and this one is containing a 30 degrees plus another angle. So we partially know the two other angle values of this large triangle. But how can we find these missing parts? Well, whenever we don't know something, the most direct way to solve for that is to set it as a variable. So we're going to call this angle A and call this angle B. What do we know about A and B? Well, as we can see, 20 plus A is just angle A, and we add that to angle B, which is 30 plus B, and then we add that to X. And X we don't know yet. We know that the interior angle sum of this large triangle must be 180 degrees. Now, if we take a look at this smaller triangle right here, we see that A plus B plus 90 degrees will also have to equal 180 degrees. So now we have two different equations to solve for two different variables. So we know that this system of equations will have to work out. Let's first start by simplifying each of these. So the first one we can turn into 50 plus A plus B plus X is equal to 180 degrees. We'll call this equation 1. We'll call A plus B is equal to 90 degrees, equation number 2. Now we can substitute. So substitute equation number 2 into equation number 1, which gives us 50 plus 90 plus X is equal to 180 degrees. If we subtract 140 degrees from both sides, we get X is equal to 40 degrees. So in the end, our final answer to this last problem is 40 degrees. So the conclusion from these two problems is that when approaching angle chasing problems, we really have to try, especially in triangles, we are trying to find the interior angle sum. Once you know 2 out of the 3 angles of a triangle, you can always find out the other one. And in both of these cases, it really involved 2 different triangles, right? We were working with essentially a big triangle and a smaller triangle. Also, in the second problem, we have a big triangle and a smaller triangle. Definitely many more solutions out there, so if you see that you have your own solution that maybe we didn't talk about, feel free to put it in the comments down below. Thank you so much for watching this video, and we'll see you in problem 2.